Welcome back to our third video in Computer Networking and Cybersecurity series. So far, we have covered the basics of how networks are structured and what makes up the Internet. Now, we are going to talk about the heart of network communication, protocols. In this video, we will explore what protocols are, why they are essential, and dive deep into some mostly common protocols like HTTP, IP, TCP, and DNS. Hi again, I am Mishri Patel, and today we are going to take a closer look at network protocols. These protocols are the rules and the standards that allows devices to communicate with each other. Without them, data wouldn't know how to travel and how devices would understand each other's messages. Let's break it down. Think of protocols as a common language or set of rules that devices use to communicate. Just like how we follow grammar rules when speaking or writing, protocols ensure that data is sent and received in a way that devices can understand. Protocols define how data should be packaged, transmitted, and processed between devices. They ensures that data from a web server reaches your browser correctly, that emails are sent securely, and that video streams without buffering. Now that we know what protocols are, let's dive into some of the most common protocols. These protocols are the backbone of the web and make sure our communication is seamless. Now, first one is HTTP, Hypertext Transfer Protocol. What it is? HTTP is a protocol used for transferring web pages over the internet. It is the foundation of data communication on World Wide Web (WWW). When you access a website, your browser sends an HTTP request to the server hosting that site, and the server responds with the requested web page. Now, how it works. HTTP operates as a request response protocol where the client, which is the browser, sends an HTTP request to the server, example asking for a web page. The server processes the request and sends an HTTP response back to the client containing the requested page or resource. Now, have you noticed some links have HTTP and some links have HTTPS? So, let's know what's the difference between both of them. So, the HTTP is not secure. Data is sent in plain text, while the HTTPS is a hypertext transfer protocol, and the S is for secure, which encrypts data using SSL or TSL, which is the secure socket layer, or the transfer layer security, making it secure for sensitive transactions like online shopping or banking. So let me give a real world example. Visiting a site like www.google.com or www.example.com involves HTTP as well as HTTPS requests and responses. What is TCP? TCP is a transmission control protocol, which is also known as a connection oriented protocol, which is used for reliable data transmission across the internet. It ensures that data sent from one device arrives at its destination intact, in the correct order, and without errors. So, how does this work? TCP breaks down data into smaller packets for easier transmission. Each packet contains a sequence number to ensure that the packets are reassembled correctly at the receiving end. If any packet is lost or corrupted during transmission, TCP ensures it is retransmitted. So, for doing this process, there are three key phases of this protocol. The first one is connection establishment. TCP uses a process called handshaking to establish a connection between the sender and the receiver. This ensures both sides are ready to communicate. The second one is data transfer. The actual data in the form of packets is sent across the connection. Connection termination is the third phase. Once the data is delivered, the connection is closed. Let me give a real-world example for this protocol. Whenever we are sending an email or downloading a file, TCP ensures that the email arrives complete and that the file download happens without missing pieces. So this is where the TCP protocol comes in use. Now comes the IP, Internet Protocol. IP is the protocol responsible for addressing and routing packets across the network. Every device connected to the internet has a unique IP address, which serves as an identifier so that data can be routed to the correct destination. Now, how does this protocol works? When a device sends a data packet, the packet contains both the source IP address where the data came from and the destination IP address where the data is going. The routing system, which is the routers, uses these IP addresses to forward packets across the different networks until they reach their destination. So, there are different versions of IP. IPv4, which is the most commonly used version with 32 bits addresses. However, due to the growing number of devices, we are running out of available IPv4 addresses. So now there is a newer version which is IPv6, which has 128-bit addresses, which significantly increases the number of possible addresses. Let me give you a real-world example. When you connect to a website, the IP address of the server hosting the website is used to route data to and from your device, which is where IP protocol is used. Now comes the most important topic, DNS, Domain Name System. Domain Name System is a naming system for resources on the internet. It translates human-readable domain names, for example, www.google.com, into machine-readable IP addresses, for example, 192.168.1.1. Now, how does it renames this? When you type a domain name into your browser, the browser queries a DNS server to resolve the name into the corresponding IP address. DNS resolution typically involves multiple layers. The first one is DNS resolver. The initial point of contact for a DNS query usually provided by the Internet Service Provider, ISP. Then comes root DNS servers. The first step in resolving the domain name, guiding the query to the correct top-level domain server like .com or .org. Then comes the authoritative DNS servers. This servers contains the actual IP address for the requested domain. Once the IP address is found, the browser can use it to access the correct server and load the website. So let me give you a real-world example. When you type www.google.com into your server, DNS translates this domain into the IP address of Google's server to establish the connection. Cap. We have learned that protocols are essential rules that allows devices to communicate, and we have covered some of the most important protocols like HTTP and HTTPS for web communication, TCP for reliable data transmission, IP for routing data to the right destination, DNS for translating domain names to IP addresses. These protocols work together to ensure smooth communication between devices, from the browsing the website to sending emails. Next video, we will discuss network performance and how they are evaluated among all of us. Don't forget to like, subscribe and hit the bell icon to stay updated on all the latest content. Until then, stay secure and keep learning.